If you watch the My Stable Diffusion video, then you know how AI learned to generate images, like type a prompt and outcomes an image. Then what about video? Video isn't just one frame, like 1,000 of frames, they need to stay consistent. Like the motion has to make sense and the character can't just transport between shots. Then how do you begin to model that? That's what today's paper is about. Stable Diffusion changed image generation. Sora does the same thing for video. But video isn't just images, it's thousands of frames that need to stay consistent over time. Motions, physics, characters, all connected. So how do you model that? Generate up to 60 seconds of a full HD video, any aspect ratio, any duration, portrait for mobile, landscape for cinema, square for social. One model handles all of it, text prompt in, video out. That alone is remarkable. Here's the key idea. Don't think of video as frames. Think of it as space-time patches. Small 3D chunks that cover both space and time at once. Compress them, flatten them into a sequence. Feed them into Transformer. This is the entire trick. This is from the paper. Video frames go through a visual encoder, get compressed into a 3D patch grid, then flattened into a 1D sequence. It's the same idea as image patches in Vision Transformers, but extended to time. That extension is what makes video generation possible at this scale. It's a diffusion transformer, not a UNAT, a DIT. There are three reasons why. UNAT struggles to scale to long sequences. Transformers don't. Transformers handle the variable length input naturally, which is perfect for patches of any video, and transformers scale predictably with compute. That last point is critical. It means the more you invest, the better it gets. Stable diffusion, but across time. Pure noise across all frames, gradually denoised into a coherent video. Look at this. You start with random noise across every frame, step by step, structure emerges. By the end, you get a complete, temporally consistent video. Your prompt controls every denoising step. But here's something interesting. Training videos often have short or missing captions, so OpenAI used GPT-4v to write detailed descriptions for every training video. More detailed captions means better prompt following. And Sora can also take an image as input. Clip encodes it and it gets injected alongside your text. Most video models are locked to one resolution. Sora isn't. Portrait, landscape, square, short clip or 1 minute film. The same model handles all of it. This works because Sora trains on videos at their native resolutions, so it learns to compose scenes correctly for each format. These are real outputs from the paper, all generated from text. The variety here is not about different models. It's all one model, handling completely different visual styles and scenes. Look at this, a robot toy walking through a snowy cobblestone street. The lighting is consistent. The shadow move correctly. The snow physics look real. Reflections on the wet ground. This came from a text prompt. Sora isn't just generating video, it's learning how the world works. Objects stay consistent as the camera moves. Characters stay coherent across many seconds. Physical interactions look real. None of this was programmed, it emerged from scale. Base compute produces blurry video with motion artifacts. 4x compute is noticeably sharper. 32x compute gives near photorealistic results with smooth, natural motion. Same architecture as GPT. Same scaling laws. The transformer is what makes this possible. Programmed these, they appeared from scale, physics, perspective, emotion. A single prompt scanning multiple scenes. Facial expressions that look natural. None of this was in the training objective, it just appeared. So things wrong, a cookie gets eaten and then reappears. Left and right get mixed up. Characters drift in very long clips. OpenAI is upfront about these. These aren't bugs, they're signs of what the model hasn't learned to model yet. The gap between imagination and video is closing. Independent creators can generate cinematic footage without cameras. Game developers can generate environments from text. Robots can train in simulated environments without real-world data. Scientists can visualize systems that were previously impossible to film. Sora isn't just generating video, it's learning to model how the words work. Nobody told it about physics or perspective over time. It figured those out by watching enough video. And if scaling keeps working the way it has, the next version won't just simulate video, it might simulate reality well enough to train robots, run experiments, and build worlds. Quickly compare Sora to DDPM, which we covered before. DDPM works on single images in pixel space with UNAT. Sora works on video frames in latent space with a diffusion transformer. Text, image, or video as conditioning. That's the evaluation in 3 slides. It wasn't the first video AI, but Sora changed the ceiling. 60 seconds full HD, any aspect ratio. The biggest leap in quality and length the field has seen. With great power comes real risk. Photorealistic video over real people doing things they never did. Fake news footage indistinguishable from real events. OpenAI hasn't publicly released Sora yet. Red team testing is ongoing. Watermarking and detection tools are being built alongside the model. Sora is version 1. 60 seconds is the current limit. Future versions will go longer. Physics will get more accurate. Generation will get faster. And more conditioning inputs like voice, music, and motion capture are coming. What Stable Diffusion did for images, Sora is doing for video. An entirely new creative industry is being built on top of this. The question isn't whether video AI will change everything, it's how fast. 3 things to watch. When Sora goes public, that's a major moment. The open source community is already building alternatives. Watch for a stable diffusion moment for video, and apps built on top of video AI are already emerging. Sora treats video as spacetime patches, not individual frames. A diffusion transformer denoises patches instead of pixels. One model handles any resolution, aspect ratio, and duration. Scaling compute dramatically improves quality, just like GPT, and Sora is learning to simulate the physical world, not just generate video. A few years ago, generating a 2-second video was considered a breakthrough, and Sora's generates 60 seconds. That's the pace we are moving at.